Go outside tonight, somewhere dark, and look up. If the sky is clear, you will find a faint band of light stretching across it, like a river of mist frozen in place. That band is our galaxy, the Milky Way, and you are looking at it from the inside. Every star you have ever seen with your own eyes lives inside that band. Every constellation, every point of light anyone has ever named, all of it belongs to this single galaxy. From where you stand, it feels like everything. It feels like the whole of existence, but it is not even close. Because tonight, we are going to do something that changes how you see your place in all of it. We are going to start right here with our home galaxy, and then we are going to zoom out, one step at a time, past the Milky Way, into the group of galaxies that holds it, past that group into a cluster, past the cluster into something so vast it was only discovered in your lifetime. And we will keep going, out past the cosmic web, all the way to the very edge of what human eyes can ever see. At every step, the thing that felt enormous a moment ago will shrink into a speck. And by the end, you will really understand how small we are. Not to frighten you, to do the opposite. Because here is the strange and beautiful part. A creature small enough to stand on one tiny planet, in one ordinary galaxy, has somehow measured all of this. We have mapped the whole thing, from our own back garden to the edge of the observable universe. And the story of that map is one of the most astonishing things our species has ever done. I want to make one promise before we begin, the same one I always make. Everything you hear tonight is real and measured and grounded in actual science. When we reach the edges of what we truly know, I will tell you plainly, I will never hand you a guess dressed up as a fact. So settle in and let the day fall away. We are going to travel outward, gently, from that faint band of light in the sky, all the way to the boundary of everything. And we begin at home, with the galaxy you are standing inside of right now. So let us begin at home, our galaxy, the Milky Way. It is a vast, slowly turning disk of stars, gas, and dust, wound into graceful spiral arms that sweep out from a bright, crowded center. Picture a cosmic whirlpool, frozen in the dark, glowing with the light of hundreds of billions of suns. And it is enormous. The disk stretches about 100,000 light years across. That number is easy to say and impossible to feel, so let me try to make it real. Light is the fastest thing in the universe. It could circle the entire Earth more than 7 times in a single second. And yet, to cross our galaxy from one edge to the other, that same light would need 100,000 years. A beam of light leaving one side of the Milky Way today would not reach the other side until long after every person alive tonight is gone, and their descendants 100 generations later too. Now, where are we inside all of this? Not at the center, not out at the lonely edge. Our sun sits about 26,000 light years from the galactic core, a little more than halfway out. If the Milky Way were a great city, we would be living in the quiet suburbs, far from the blazing, crowded downtown, out where things are calmer and more spread apart. And we are not sitting still. Our whole solar system is racing around the center of the galaxy at about 500,000 miles per hour. At that speed, you would cross from London to New York in under a minute. And still, the galaxy is so unimaginably large that one full lap around, it takes our sun roughly 230 million years. Scientists call that single trip a galactic year. Sit with that for a moment, because it reframes everything. The last time our sun was in this exact spot on its orbit, dinosaurs had not yet appeared on Earth. In the time it takes to go around just once, entire chapters of life have risen and vanished. And in its whole long lifetime, our sun has only managed about 20 of these laps. 20 galactic years. That is the age of our star. Now let us look at what fills this disk. Somewhere between 100 and 400 billion stars. We cannot count them exactly, and there is a strangely humbling reason why. We are trapped inside the galaxy, embedded in the disk, with vast clouds of gas and dust blocking our view in every direction. We simply cannot step outside and take the photograph. We are trying to map the whole house while standing in one room of it in the dark. But even the smallest of those estimates is a number the human mind cannot truly hold. Imagine trying to count 100 billion stars, one every second, without ever stopping to sleep or rest. It would take you more than 3,000 years to finish. And most of the stars you counted would be small, cool, dim red stars, quietly burning away, some of them older than the sun, destined to still be shining long after it has died. And at the very heart of this whole spinning city, holding everything together, sits something almost beyond imagining. A supermassive black hole called Sagittarius A star. Its mass is about 4 million times the mass of our Sun, and yet all of that is crushed into a region smaller than the orbit of Mercury. Every star in the galaxy, including ours, is in some slow, grand sense orbiting around it. It is the anchor at the center of our cosmic home. So this is the Milky Way, 100,000 light-years wide, hundreds of billions of stars, a monster black hole at its core, and our own small sun drifting through the suburbs, carrying us along on a journey that takes 230 million years just to come back to where it started. And it would be easy to stop here and simply feel small. But we have not even begun. Because everything I have just described, this entire glittering disk, is only the part we can see. Wrapped around it, unseen, is something far larger, and our galaxy is not alone out there. It has a giant twin, drifting closer with every passing second, on a collision course that will one day reshape the sky entirely. That is where we go next. So here is the first surprise, and it is a big one. Everything I just described, the whole glittering disk of the Milky Way, is not the whole galaxy. It is barely the core of it, because wrapped around that bright disk is something we cannot see at all. A vast, invisible sphere called the dark matter halo. It is made of that mysterious, unseen substance that gives off no light but has gravity. And this halo is enormous. While the visible disk is about 100,000 light-years across, the dark halo surrounding it stretches close to 2 million light-years wide, roughly 6 times the size of everything we can actually see. Now here is the part that reorders your whole sense of things. That invisible halo is not a minor add-on. It is most of the galaxy. When you weigh the Milky Way, the stars, the gas, the dust, all the shining matter we have ever detected, it accounts for only about 15% of the total mass. The other 85% is the dark halo. The glowing galaxy we admire in every photograph is just the bright tip of something far larger, hidden in the dark. Let me put that plainly. Almost everything our galaxy is made of, we cannot see. The stars are the exception, not the rule. We have been staring at the small, lit-up part of our home our entire history, never seeing the vast, dark shape it truly sits inside. But even with that invisible halo included, our galaxy is not alone. And this brings us to something drifting toward us in the dark right now. Its name is Andromeda. It is another great spiral galaxy, much like our own, and it is our nearest large neighbor. It sits about 2.5 million light-years away. That distance is worth pausing on, because it means something haunting. The light you would see from Andromeda tonight left it 2.5 million years ago. You are not seeing it as it is now. You are seeing a photograph 2.5 million years old, from a time before modern humans even existed. When that light began its journey, our earliest ancestors were just beginning to walk the Earth. And Andromeda is not sitting still. It is falling toward us, drawn by gravity, closing the gap at about 110 kilometers every second. Even now, as you rest, our two galaxies are rushing toward one another across the dark. For a long time, the story was simple. Everyone agreed the two galaxies were destined to crash together in around 4 to 5 billion years, merging into one giant galaxy. But I promised you honesty, and the science has recently grown more interesting, because in the last couple of years, astronomers ran the most careful simulations yet, and the certainty softened. Some of these studies now put the collision at closer to a coin flip. It might happen, it might not. The pull of other nearby galaxies could nudge us just enough to sail past instead. We simply do not know for certain anymore, and that honest uncertainty is more fascinating than the tidy answer we used to give. But suppose it does happen. You might picture unimaginable destruction, stars smashing into stars, worlds shattering, and here is the beautiful truth. Almost nothing would actually collide, because space is so staggeringly empty. The stars inside a galaxy are so far apart, with so much darkness between them, that when two galaxies pass through each other, the stars simply glide past, like two swarms of fireflies drifting through one another without a single one touching. The galaxies would be reshaped and eventually merged, but the stars themselves would almost never meet. So this is our immediate neighborhood, our galaxy, cloaked in its enormous invisible halo, drifting alongside a giant twin, the two of them bound together by gravity across millions of light years of empty space. And now notice what is happening. We began with the Milky Way, and it felt like everything. Then we found it was mostly invisible. Then we found it has a giant companion, and already the picture is growing, because the Milky Way and Andromeda are not just two lonely galaxies, they are the two largest members of a much bigger gathering. A whole family of galaxies bound together, drifting through space as one, and that family is where we go next. So let us take our first real step back and widen the view. Our galaxy and Andromeda are not a lonely pair. They belong to a family. Scientists call it the local group. The local group is a collection of galaxies, all bound together by gravity, drifting through space as a single cluster. And it is not small. It stretches about 10 million light years across. Remember, our entire Milky Way, the thing that felt like everything just a few minutes ago, is only 100,000 light years wide. So the local group is around 100 times larger than our whole galaxy. Already, our home has shrunk from the entire universe to one member of a much bigger crowd. And how many galaxies are in this family? We currently know of more than 80. That number keeps growing because many of them are so small and so faint that we are still discovering them, hiding in the dark right on our doorstep. Now here is something that quietly humbles you. You might assume that our Milky Way and Andromeda are typical members of this group. They are not. They are the giants. The two of them, along with a third, smaller spiral called Triangulum, are the heavyweights, holding most of the mass and the light. Almost everything else in the local group is a dwarf galaxy. Small, dim, sometimes holding only a few million stars instead of hundreds of billions. These little galaxies drift around the big ones like moons around planets, faint and easy to miss. Some of them hold fewer stars than a single one of the Milky Way's spiral arms. So the picture is not a grand assembly of equal giants. It is 2 or 3 large galaxies surrounded by a scattered swarm of small, quiet ones. We happen to live in one of the big ones, which is a little like being born in the largest house on a street of tiny cottages. It can fool you into thinking you are the center of things. You are not. And there is something beautiful about how this family holds together. Remember that the universe as a whole is expanding, with galaxies everywhere racing apart from one another. But not here. Inside the local group, gravity wins. These galaxies are bound so tightly to each other that they resist the expansion of the universe entirely. While the rest of the cosmos stretches ever wider, our little family stays together, holding hands across the dark, refusing to drift apart. It is an island of togetherness in an expanding sea. Let me try to give you a feel for the emptiness inside it though, because that matters too. Between our Milky Way and Andromeda lie 2.5 million light-years of almost perfect nothing. If you shrank the Milky Way down to the size of a dinner plate, Andromeda would be another dinner plate, sitting about 8 feet away, and the space in between would be almost entirely empty. That is what a galaxy group really is. A handful of islands of light scattered across an ocean of dark, held together only by invisible threads of gravity. Now, step back and feel where we have arrived. We started standing inside the Milky Way, and it filled our whole sky. Then we learned it was mostly invisible dark matter. Then we found it had a giant twin, and now we see that both of them are just two members of a family of over 80 galaxies, most of which are so small we barely notice them. The thing that felt like everything has become one house, on one street, in one neighborhood. And here is the pattern you can already feel building. Every time we think we have reached the edge of something, we pull back and discover it was sitting inside something far larger all along. It has happened 3 times now, and it is about to happen again on a scale that dwarfs everything so far. Because the local group, this entire family spanning 10 million light years, is itself just a tiny outlying member of a structure so vast it contains thousands of galaxies. Our whole family is about to become a single dot on the edge of something enormous, and that is where we go next. So now we pull back again, and the scale takes a genuine leap, because our whole local group, that family of 80 galaxies spanning 10 million light years, turns out to be sitting on the outskirts of something enormous, something anchored by the nearest great city of galaxies. It is called the Virgo cluster. Remember, our local group is dominated by 2 or 3 large galaxies, with everything else being small dwarfs. Now hold that in mind, because the Virgo cluster is a different order of thing entirely. It does not contain dozens of galaxies. It contains somewhere between 1,300 and 2,000 of them. Great spirals and giant ellipticals, packed together far more densely than anything in our quiet corner. If our local group is a small village, the Virgo cluster is a roaring metropolis, blazing with the light of thousands of galaxies crowded close. And it sits about 54 million light years away. Take a moment with that number, because it is a kind of time machine. The light reaching us from the Virgo cluster tonight left it 54 million years ago. When that light set out, the dinosaurs had already been gone for over 10 million years, and the very first small mammals were just beginning to spread across a recovering Earth. That is how long this light has been traveling, just to show us our nearest great cluster. But here is the part that matters most. The Virgo cluster is not simply a neighbor we can point to. It is the heart of the structure that contains us. Because our local group and the Virgo cluster and around 100 other groups and clusters are all part of a single vast structure called the Virgo supercluster. Our home supercluster, and its size is staggering. The Virgo supercluster stretches about 110 million light years across. Let me stack that up against where we have been, so you can feel the climb. Our galaxy, 100,000 light years, our local group, 10 million, and now our supercluster, 110 million light years wide, holding tens of thousands of galaxies. Each step outward has multiplied the scale again and again, and we are still nowhere near the edge. Now, where do we sit inside this supercluster? Not at its heart, not anywhere near the blazing Virgo cluster at its center. Our local group lies far out toward the edge, in a thin, sparse, unremarkable region. One writer described our little corner as a wimpy filament, a faint thread on the outskirts, and honestly, that is a fair description. We are not in the bright downtown of our own supercluster. We are out in the far, quiet, dimly populated suburbs at the very rim. And yet, even from way out here on the edge, we can feel the center pulling on us. The enormous mass of the Virgo cluster, all those thousands of galaxies, exerts a gravitational tug across all that distance. Our entire local group is slowly falling toward it, drawn inward at hundreds of kilometers per second. Scientists even have a name for this gentle, inward drift. They call it the Virgocentric flow. We are quietly sliding toward the heart of our supercluster, pulled by the gravity of everything gathered there. So let us take stock of how far we have come. We started inside the Milky Way. We found it was mostly invisible. We found it had a twin. We found it lived in a family of 80 galaxies. And now that whole family has become a single faint thread on the outer edge of a supercluster containing tens of thousands of galaxies, stretching 110 million light-years across. You would think, surely, that a supercluster must be near the top of the ladder. Surely, at 110 million light-years, holding 100 clusters, we have reached something close to the largest scale there is. And for a long time, scientists thought exactly that. They believed the Virgo supercluster was our final, largest home. But they were wrong, because in the year 2014, a team of astronomers made a discovery that redrew the map completely. They found that our entire supercluster, this whole vast structure, is not a home at all. It is just one small lobe, one outlying petal, of something hundreds of times larger. And when they finally saw the true shape of the thing we live inside, they gave it a name that means immeasurable heaven. That discovery is where we go next. So, in the year 2014, a team of astronomers led by Brent Tully, working in Hawaii, tried something no one had quite done before. Instead of just mapping where galaxies are, they mapped how they are moving. They tracked the motions of thousands upon thousands of galaxies and watched which way each one was drifting through space. And when they did, a hidden shape appeared. Because galaxies do not drift randomly. They flow, like water, and just as every drop of rain in a valley slowly runs downhill toward the same river, the astronomers found that all the galaxies across a truly vast region were flowing together, streaming toward one common point. By following those flows, they could finally trace the true outline of the enormous structure we live inside. And it was far, far bigger than anyone had realized. They named it Laniakea. It is a Hawaiian word, and it means immeasurable heaven. The name honors the ancient Polynesian navigators who once crossed the vast Pacific, guided only by the stars. And it is a perfect name, because the thing they mapped is almost beyond measure. Here is its scale. Laniakea stretches about 520 million light-years across, and it contains around 100,000 galaxies. Let me place that on the ladder we have been climbing, because this is the moment it becomes almost unbelievable. Our galaxy was 100,000 light-years wide. Our whole Virgo supercluster, which felt gigantic just moments ago, was 110 million, and Laniakea is 520 million light-years across, holding 100,000 galaxies. Our entire former supercluster, that whole vast structure, turns out to be just one small lobe of this. One petal on a much larger flower. And at the heart of Laniakea, at the bottom of that great valley all the galaxies are flowing toward, lies a mysterious region called the Great Attractor. It is not a single object you could point to. It is a place, an immense concentration of mass, pulling galaxies from across hundreds of millions of light-years toward it. Our Milky Way, our local group, our whole neighborhood, all of it is being drawn in that direction at around 600 kilometers every second. Right now, as you rest, you are being carried toward the Great Attractor faster than any rocket humanity has ever built. But here is where I have to keep my promise and tell you something honest, because it is stranger and sadder than the simple story. We will never actually arrive. We are flowing toward the Great Attractor, yes, but we will never reach it, because Laniakea, for all its vastness, is not truly held together. Unlike our tightly bound local group, this enormous supercluster is too spread out for its own gravity to win, and the expansion of the universe, that relentless stretching of space, is slowly pulling it apart faster than gravity can gather it in. So Laniakea is not a stable home. It is a temporary gathering, a vast structure in the slow process of dissolving, It's galaxies destined to drift away from one another over billions of years, carried off by the expanding cosmos before they ever reach the valley they are falling toward. Sit with that for a moment, because it is a beautiful and melancholy thing. We finally discovered the true shape of our cosmic home, only to learn that it is not permanent, that it is quietly coming undone, even as we map it. Now look back at the journey we have taken. We began standing inside the Milky Way, and it was our entire sky. Then it became one galaxy among 80 in the local group. Then that group became a faint thread on the edge of the Virgo supercluster. And now that whole supercluster has become a single lobe of Laniakea, a structure 520 million light-years wide, holding 100,000 galaxies, all of them flowing toward a valley they will never reach. 5 times now, the thing that felt like everything has shrunk into a speck inside something larger. And you might finally think, surely this is the top. Surely Laniakea, immeasurable heaven itself, is the grandest structure there is. But it is not, because Laniakea, with all its 100,000 galaxies, is just one node in a web. A single bright knot in a pattern that stretches across the entire universe, connecting everything that exists into one enormous, glowing structure. It is the largest thing that has ever been found, and it is where we go next. So we arrive at the largest structure in all of existence. Scientists call it the cosmic web, and it is exactly what it sounds like. If you could pull far enough back to see the entire universe at once, past the galaxies, past the clusters, past even Laniakea, you would not see things scattered randomly through the dark. You would see a pattern, an immense glowing network, stretching in every direction as far as anything can see. Galaxies are not sprinkled evenly across space. They are strung together along vast, luminous threads. These threads are called filaments, and they are almost impossible to imagine. Each one is a river of thousands of galaxies, stretched into a line that can run for hundreds of millions of light years. And where these filaments cross and tangle together, they form dense, blazing knots. Those knots are the great galaxy clusters and superclusters, the brightest gatherings of galaxies in the universe. Laniakea itself, our home, with its 100,000 galaxies, is simply one of those knots. One bright junction in a web that spans everything. And between the glowing threads lies the strangest part of all: emptiness, because the filaments do not fill space. They wrap around enormous, nearly perfect bubbles of nothing. Scientists call these bubbles voids, and a single void can be hundreds of millions of light years across, containing almost no galaxies at all. Vast, silent, dark spheres of near total emptiness, with the bright threads of galaxies draped around their edges, like glowing nets around soap bubbles. Let me try to help you picture the whole thing. Imagine a sponge, with its solid material forming a connected network of walls and strands, and its holes being the empty spaces. The universe, on the largest scale, looks like that. Or imagine the foam on top of a glass, all those bubbles pressed together, with the thin films between them holding everything. The galaxies live in the films, the insides of the bubbles are the voids. That is the shape of the cosmos itself, and here is the image that stops scientists in their tracks. When you look at a map of the cosmic web, all those bright filaments connecting glowing knots across a dark background, it looks almost exactly like something you have seen before. It looks like a network of brain cells. The filaments of the universe, strung with galaxies, look uncannily like the neurons in a human brain, connected by their thread-like branches. The largest structure we know of, and the thing inside your own head that is comprehending it, share the same haunting pattern. Nobody is saying the universe is a brain, but the resemblance is real, and it is difficult to look at and not feel something. So how did this vast web come to be? The answer reaches all the way back to the beginning of everything. In the very early universe, matter was spread out almost perfectly smoothly, but not quite. There were tiny ripples, faint regions where matter was a little more dense than average. And over billions of years, gravity did patient, relentless work. It pulled matter toward those denser spots. The dense regions grew denser, gathering galaxies along the threads, while the emptier regions were slowly drained, growing into the great voids. What began as the faintest whisper of unevenness became, across the whole age of the universe, this magnificent web. The cosmic web is gravity's masterpiece, sculpted over 13.8 billion years. Now feel where we stand. We have climbed all the way from our own planet, out through the galaxy, the local group, the supercluster, Laniakea, and now to the cosmic web itself, the grandest structure that exists. There is nothing larger. This is the top of the ladder of things. And yet, we are not finished. Because there is one more limit to face, not a bigger structure, but a boundary. Because no matter how powerful our telescopes become, there is a wall we cannot see past. A hard edge to everything we are able to observe. The cosmic web stretches on beyond it, but we can never see how far. And the reason for that edge is one of the most mind-bending ideas in all of science. It is where we go next. So we have reached the largest structure that exists, but now we run into something different. Not a bigger object, but a limit, a boundary on how much of the universe we are able to see at all. Scientists call it the observable universe, and understanding why it exists changes everything. Here is the idea, and it rests on two simple facts. The first is that light takes time to travel. It is fast, unimaginably fast, but it is not instant. When you look at the sun, you are seeing light that left it 8 minutes ago. When you look at Andromeda, you are seeing light that is 2.5 million years old. The farther away something is, the further back in time you are seeing it. To look out into space is always to look into the past. The second fact is that the universe has an age. It has not existed forever. It began about 13.8 billion years ago in the Big Bang. And that single fact creates a hard wall around everything we can see. Think it through with me. Because the universe is 13.8 billion years old, light has only had 13.8 billion years to travel toward us. So the most distant light that could ever reach us is light that has been traveling for the entire age of the universe. Anything farther away than that, its light simply has not had enough time to arrive yet. It is still on its way, crossing the gulf, and it will not reach us for millions or billions of years more, and some of it will never reach us at all. So there is a boundary, a sphere around us, marking the farthest distance from which light has had time to arrive. Scientists call this the cosmic horizon. Inside that sphere is everything we can observe. Every galaxy, every cluster, every strand of the cosmic web that we have ever detected. And outside it, hidden beyond that horizon, is more universe that we cannot see, because its light has not reached us, and in many cases never will. It is a little like standing in the middle of the ocean in thick fog. You can see the water for a certain distance in every direction, out to where the fog closes in. That circle around you is all you can observe. But you know, with complete certainty, that the ocean does not end where the fog begins. It goes on, far beyond what you can see. The horizon is not the edge of the ocean. It is only the edge of your view. And here is a subtle, beautiful consequence of this. You are always at the exact center of your own observable universe. So am I. So is every creature on every world, anywhere in the cosmos. Each of us sits at the middle of our own personal bubble of visible space, with the horizon the same distance away in every direction. But this does not mean we are at the center of the universe. We are not. It only means that we can see the same distance every way we look. An alien in a distant galaxy would have their own bubble, centered on themselves, seeing a different slice of the cosmos, with parts we can see hidden from them and parts they can see hidden from us. There is no true center. There are only countless overlapping bubbles of sight, scattered across a universe far larger than any of them. So the observable universe is not the whole universe. It is only the part close enough for its light to have found us in the time available. It is our bubble of visibility, floating in something vastly larger. Now, How big is that bubble? This is where the story takes its final, strangest turn. Because you might reason it out very simply. The universe is 13.8 billion years old, so light has traveled for 13.8 billion years in every direction, which would make our bubble about 27 billion light years across. That is the obvious answer. It is also completely wrong, because the true width of the observable universe is not 27 billion light years. It is far larger, and the reason why is one of the most mind-bending facts in all of science. It is where we go next. So the obvious answer is 27 billion light years, and it is wrong. The real width of the observable universe is about 93 billion light years, more than 3 times larger than the simple math suggests. To understand why, we have to add in the single most important fact about the universe. It is expanding. Here is the problem with the simple answer. It quietly assumes that space stays still while light crosses it. But space does not stay still. Space itself is stretching, growing larger in every direction all the time, and that changes everything about distance. Let me give you the picture that makes it click. Imagine an ant walking across a rubber band toward you. The ant moves at a steady, slow pace. But while it walks, you are also stretching the rubber band, pulling it longer and longer. So even though the ant only ever crawls at its own slow speed, by the time it reaches you, it has actually covered a distance far greater than the rubber band was when it started. The stretching added extra ground beneath its feet. Light in the expanding universe is exactly like that ant. When a distant galaxy sent out the light we are seeing tonight, that galaxy was relatively close to us. The light set off at its own steady speed. But over the billions of years it took to arrive, space itself kept stretching, and the galaxy that sent it was carried farther and farther away the whole time. So think about what that means for the most distant light we can see. That light has been traveling for about 13.8 billion years. But the galaxies that emitted it are not 13.8 billion light years away anymore. Space has been expanding this entire time, carrying them ever outward. And today, those source objects are now about 46 billion light years away from us. The light left them when they were close. It arrived after an epic journey, and in the meantime, they have been swept far, far beyond where they were. So, our observable bubble reaches about 46 billion light years in every direction. Double that, edge to edge, and you get the true diameter, about 93 billion light years across. Not because light traveled that far, but because space stretched while it did, and the farthest thing we can see, right at the very edge of that bubble, is something we have already met on this journey. It is the cosmic microwave background, the ancient glow left over from the Big Bang itself. It is the oldest light in existence, and it marks the boundary of everything observable. Beyond it, we cannot see, because before that light was released, the universe was an opaque fog, and no light could travel at all. So the edge of our vision is not the edge of the universe. It is simply the moment the universe first became clear, 13.8 billion years ago. Its light stretched across an ocean of expanding space to reach us tonight. Now, take a breath and feel the full size of what we have climbed. Our observable universe is a sphere 93 billion light years across, and within it, astronomers estimate there are around 2 trillion galaxies. Not 2 trillion stars, 2 trillion galaxies. And each one of those galaxies holds, on average, hundreds of billions of stars of its own. The numbers spiral so far beyond human understanding that they stop being numbers at all and become a kind of poetry. And here is the humbling thing to hold on to. This is only the part we can see. Our 93 billion light-year bubble, with its 2 trillion galaxies, is not the whole universe. It is only our bubble of visibility, the region close enough for light to have reached us. The real universe stretches on beyond that horizon, and we have no way of knowing how far. So the final question is the one we cannot fully answer. How much bigger is the whole universe than the part we can see? Is it just a little larger, or unimaginably larger? Or does it go on forever without end? We have reached the boundary of what our eyes and telescopes can ever show us. And what lies past it is the deepest unknown of all. That is where we go next. So we stand at the very edge of what we can see, and we ask the last question. How big is the whole universe, really? And here I have to be completely honest with you, because we have reached the boundary not just of our vision, but of our knowledge. The truthful answer is this: we do not know, and we may never know, but we can say a few careful things about it. The first is that the whole universe is definitely dramatically larger than the part we can see. Our observable bubble is 93 billion light years across, but that is just the region whose light has reached us. The best measurements we have suggest that the full universe extends far beyond it. Some careful estimates say the whole universe is at least hundreds of times larger than the observable part, and that is only the cautious flaw. The real answer could be far, far greater than that. To understand why, think back to the very beginning of the universe, to that burst of sudden expansion called inflation. In its first tiny fraction of a second, the universe ballooned in size by an almost unimaginable amount. And if that early stretching was as powerful as the evidence suggests, then it pushed the vast majority of the universe so far away that its light will never, ever reach us. We are left seeing only a small pocket of a cosmos that is overwhelmingly hidden beyond our horizon, forever out of view. And there is a second possibility, stranger and grander still. The universe might not just be very large, it might be infinite, truly, endlessly infinite, with no edge and no boundary anywhere. When astronomers measure the shape of space as carefully as they possibly can, they find that it appears to be flat, and a flat universe, according to our best understanding, could well go on forever in every direction without end. Sit with what that would mean. If the universe is infinite, then there are an infinite number of galaxies, an infinite number of stars. And here is the truly dizzying part. If space goes on forever, filled endlessly with matter, then somewhere out there, unimaginably far away, the same particles could arrange themselves the same way by pure chance. There could be another world exactly like Earth, another version of you, reading these same words, on a planet you will never see and can never reach. In an infinite universe, everything that can happen does happen, somewhere. It is a staggering thought, and I want to be honest that it is a possibility, not a proven fact. But it follows naturally, if the universe really is endless. So which is it? Hundreds of times larger than we can see, or truly infinite? And this is the hardest truth of the whole journey. We may never find out, because the answer lies beyond our horizon, in the part of the universe whose light can never reach us. We are sealed inside our bubble of visibility, able to study only the region close enough to see. The rest, however vast, however endless, is hidden from us by the speed of light and the age of the cosmos. It is not that we lack a good enough telescope. It is that the information simply cannot get to us. The true size of the universe may be a question that no one ever can answer. And that is a strange place to arrive. We climbed the entire ladder, from our own planet all the way to the edge of the observable universe, only to find that even this immense bubble, with its 2 trillion galaxies, may be nothing more than a tiny speck floating in something infinitely larger. We are smaller, it turns out, than even the grandest numbers of this journey could capture. It would be so easy, standing here, to feel crushed by all of it, to feel that we are nothing, a mote of dust on a speck of rock, lost in an ocean without shores. But I want to end this journey by turning that feeling completely around, because there is another way to see our smallness, and it is not sad at all. It is the most astonishing thing in this entire story, and it has nothing to do with the size of the universe, and everything to do with what we are. That is where we end. So let us turn it all around. For the whole of this journey, we have been shrinking. Every step outward made us smaller. The Milky Way became a speck. The local group became a speck. Laniakea, immeasurable heaven itself, became a speck. And finally, our entire observable universe, with its 2 trillion galaxies, became a possible speck in something infinite. By the end, we are almost nothing at all. But here is the reversal. Here is the thing I most want you to carry away tonight. You just traveled all of that, from your own back garden to the edge of the observable universe, across 93 billion light years. And you did it without leaving your seat. Every step of that ladder, every scale, every structure, every number, all of it is known, measured, mapped, and it was mapped by us, by small, soft creatures living for a handful of decades on the surface of one ordinary planet, in the quiet suburbs of one ordinary galaxy. Think about how absurd that is and how magnificent. We are, by size, almost nothing, a speck on a speck on a speck, and yet that speck figured out how far away Andromeda is. That speck weighed the invisible halo around its own galaxy. That speck discovered Laniakea by tracking the motion of 100,000 galaxies. That speck worked out that space itself is expanding and calculated the true width of everything it can see. We are impossibly small, and we have measured the immeasurable. No other thing we know of does this. As far as we can tell, the galaxies do not know their own size. The great cosmic web does not know it is a web. The great attractor does not know it is pulling anything. In all this staggering vastness, the universe is almost entirely unaware of itself. And then, on one small world, matter arranged itself into something that could look up and wonder and measure and understand. We are the part of the universe that came to know how big the universe is. We are the cosmos, looking at itself and taking its own measure. That is not smallness. That is one of the most extraordinary things that has ever happened. The size of your body is not the size of your reach. You are tiny enough to fit in a single room, and yet your understanding stretches across 93 billion light years. By that measure, the truer one, you are not small at all, you are vast. And here is the last gift of this journey. Understanding how big the universe is does not have to make you feel lost in it. It can do the opposite, because every galaxy we counted, every structure we climbed through tonight, is now a part of the world you carry in your head. You know your address now, not just your street and your town, but your galaxy, your local group, your supercluster, your Laniakea, your cosmic web, your observable universe. You know exactly where you are in the largest map that exists, and almost no one who ever lived across all of human history got to know that. You do. So the next time you step outside and you find that faint band of light stretched across the dark sky, I hope you feel something new. That band is your home galaxy, seen from the inside. Around it drifts a family of galaxies, and around that, a supercluster, and around that, immeasurable heaven, and around that, a web of galaxies reaching to the edge of sight, and beyond that edge, perhaps forever. And you are standing at the center of your own view of all of it, a small, thinking, temporary thing that somehow holds the whole map in its mind. The universe did not make you to be crushed by its size. It made you to be the thing that measures it. And that, in the end, is the answer to the question we began with. How small are we, really? Small enough to stand on one tiny world, and large enough to hold the entire cosmos in our understanding. Thank you for taking this journey outward with me tonight, all the way to the edge of everything and back. If it gave you a new sense of where you are and how remarkable it is to be able to know it, share it with someone who loves to look up and wonder too. And if you would like to keep exploring the cosmos with us, twice a week, you know what to do. Until the next journey, rest well and never stop looking up.